Okay, we're reviewing 6-4 assignment. Someone wants to do problem 56. Okay, this is the boating one. It says a buoy in the harbor of San Juan, Puerto Rico, bobs up and down. The distance between the highest and lowest point is 3 feet. It moves from its highest point down to its lowest point and back to its highest point every 8 seconds. Okay. Part A says find the equation of the motion for the buoy, assuming that it is at its equilibrium point at time equals 0, and the buoy is on its way down at that time. Okay, so if we drew a graph of this, okay, so at the time, remember, the x-axis will be time, the y-axis will be height. We did one like this last time. Do you guys remember? How many of you got this one, by the way? Just by raise of hand, how many of you guys got this one? One? That's it? How many of you didn't even try it? How many of you read the problem? How many of you guys read the problem and quit? All right. Hey, I know that some of you guys don't even, you guys see story problem and you think, I'll just ask Mr. Cahoon, you don't even try it, but I promise you guys, if you will learn to read through these and try to get them, you'll get better at them, you'll start understanding them, and it'll help you out. On what math test? CRT? There's not a CRT in pre-calculus. Yeah. Okay. I'm serious. There is no CRT for pre-calculus. Jerica. Get it from someone around you.
Where's the camera?
All right, it's right here. Did you guys know there's a camera on this thing? And it video cords you guys when I want?
It's right here.
What do you think, Sydney? No? Okay. Over time, this thing, it says that the buoy, at time equals 0, it's right here. Which way is it heading? It's heading down, right? And then it goes back up, and it goes back down, and then it goes back up, and it continues that pattern. And how far up does it go, you guys? How far up does it hit right up there and right down here? Does it go up 3 feet and down 3 feet? Read it again. Thank you, Ramon. It goes up 1.5, right? The gap between here is 3 feet. That means that this point right here is 1.5, and this down here is negative 1.5. So, you guys, based on that, do we know the amplitude? Okay, the amplitude is equal to the absolute value of 1.5. And since it's going down, okay, we should say amplitude right there. The amplitude is 1.5. But what is the value of A? What's the value of A? Which way does it head first? It's heading down, so it's a negative 1.5. Do you remember that? By the way, Sadie, thank you for doing those. Okay. She's the only one that did the problem. Anybody else do it? Dylan, did you not do it? Parker? Parker. You're my old reliable here.
Parker.
Where's Sean? Ramon. What about Ramon? Ramon usually does it. No? Oh, man. All right. Okay. All right. So, by the way, is this a sine or cosine curve? Cosine? It's a sine. Why is it a sine? It goes through 0, 0, so it's a cosine. So far, we know that y is equal to, A is 1.5, and it's negative, right? Because it goes down, and it's a sine curve. Sorry. Did I say cosine? After you guys all said sine. Sine, and now all we have to do is figure out what k is, right? Okay, how are we going to figure out K? Every 8 seconds. So what does 8 seconds represent? A period. And what's our formula for period? You guys remember this period, this formula last time? 2 pi over K. And so we know what P is. What is P? 8. So our equation is 8 equals 2 pi over K. Solve that for K, and what would we get? K equals 2 pi over 8, right? If we times both sides by K and then divided by 8. And 2/8 reduces to what? 1/4. And so K is equal to pi fourths. And so we have pi fourths times T. T is the x variable. And for y, we probably should use height. Okay? So height equals negative 1.5 sine of pi fourths T. Okay. That answers question A. Question B, determine the height of the buoy at 3 seconds. And question C, determine the height of the buoy at 12 seconds. I'm going to let you guys do those. This is a due next time, so I'm going to let you guys finish it. The thing I want you to remember that we learned last time is if we're given an equation in the form y equals a times sine of k theta, or of the form y equals a cosine of k theta, that a, the absolute value of a, is what? The amplitude. And k affects the what? The period. So the period formula is P equals 2 pi over K. You guys have got to know those two things from that last assignment. Okay? Got it? Okay, we are going to move on now. I'm going to... You guys got that written down? Because I'm going to erase this thing. So hurry and write it down if you're going to keep it. I don't know if you've seen the objectives. They're written on the board right there. However, okay, our two objectives. Number one, we're going to find the phase shift and the vertical translation for sine and cosine functions. What is phase shift? Okay, so that's the first question. What is phase shift? Well, do you guys remember when we were working earlier, we learned how to transform functions left and right, horizontal shifts? If I take y equals x squared, what's that parent function right there? What do we call that? Quadratic. Okay, what if I did this? What would happen to the function if I did this? What was that? What? Yeah, this one would shift right too. Do you guys remember doing that? 2 units. Okay. This is called a horizontal shift. In trigonometry, it is a phase shift is a horizontal shift. Okay, so a phase shift in trigonometry, it is a, wow, it's not very good English right there. Trigonometry, it is a horizontal shift. So phase shift is just the word we use in trigonometry for a horizontal shift. That's what I meant to say. What was that? How's that? Okay. Trigonometry is a horizontal shift. Okay, so I want everybody to take your calculator, and I want you to put in the following. Under y1, I want you to put sine of x, y equals sine of x. Under y2, okay, I'll tell you the window in just a second. Y2, we're going to put sine of x plus pi over 4. And y3, we are going to put y equals sine of x plus pi halves. I made a mistake right here, you guys. I should have a sign in front of it. Okay, your window. I'm going to use the window they put in this book right here, negative 4.7 to 4.8. I don't know why they use this window. And with a scale of 1. You know what? I don't know why they're using a scale of 1 either right here. I say we should use a pi half scale. Let's do this for the scale. Let's go. Let's go the x scale at pi fourths. Okay? And then y, the y window is going to be between negative 3 and positive 3. And a scale is equal to 1. Y scale equals 1. Okay? So we got those ready to go. I'm going to take the calculator and put them in mine. Okay, so my window is between negative 4.7. By the way, what mode should you guys be in? Yeah, put it in radian mode. I'm going to go pi divided by 4, negative 3, positive 3. Okay. And my y equals, first I'm going to check my mode. I'm in radian mode, so I'm good. Make sure you're in radian mode. Sine of x. Sine of x plus pi fourths. And sine of x plus pi halves. Okay. So has everybody got that? Yeah. Okay, now watch them as they graph. First one, here, we all know the sine function. Goes through 0, 0. Okay, the next function shifted over. How far? To the left. Well, what does each of these scales on the x represent? Pi fourths, doesn't it? So the second one shifted over pi fourths. How much did the third one shift over? Pi fourths plus pi fourths, which is pi halves, right? Okay, so if we go back to this right here, we looked at this sine function right here. This was the one that goes through 0, 0. The second one, and maybe I'll move these down like this. Whoops. Actually, I've got enough room right there. Okay, what happened to this one right here? This was a horizontal shift. Pi force left. And this one was a horizontal shift, right? Pi halves left. Okay? What would you think would happen if we put in the function sine of x plus? Let's go to y sub 4. What would you think would happen if you put sine of x plus pi? How far would that shift? Pi to the left. Okay, let's put that one in. sine of x plus pi and graph. Okay, shifted pi to the left. Here's pi right here. And that point right there, if you look back, the sine of x is that point that's going through 0, 0, going down that way, right? So it shifted left pi units. Okay. How do you think we're going to get this to shift right? Subtract it, okay? You guys know, let's go back to this. Okay, you guys know this form right here. Y equals, let's go sine of, by the way, I'm going to use theta instead of x right here. Theta minus c. Okay, theta minus c. That is the general form. Okay, and so when I did that one back there where it said sine y equals sine of x plus pi force, really, that was the same as sine theta equals, or I'm supposed to use theta now, right? Sine of theta minus a negative pi force, wasn't it? You guys see that? Minusing a negative pi force is the same thing as adding, right? And so you can see that the reason it shifted left is because it was actually a negative pi force. But do you remember on horizontal shifts, it shifts in the opposite direction of whatever sign is out front? Okay, so what do you guys think would happen? Predict this and then test it in your calculator to see if you got it right. Y equals sine of theta minus pi halves. What's your prediction? And then test out your prediction to see if it's right. What do you think? What do you guys all think? Okay, opposite. Just explain. Where's it going to go? What's it going to do? Shift right. How far? Pi halves. Check it out and see if it did. Okay, I'm going to clear all these out. I'm going to go sine of x minus pi divided by 2. And I'm going to graph it. Here's my sine function. Once again, it goes through 0. This comes 0. It's going up. And this function, if you notice, this point right here was the same as this point on the sine function right here. It's just shifted to the pi force plus another pi force is pi halves. That point right there is pi halves to the right. You guys understand that? Now, what happens if all of a sudden we start messing with the period of a sine function? Okay, let's say I start doing this. Let's say I have y equals sine of k theta minus c. K theta minus c. If I start putting a k in front to change the period, okay, what's going to happen? Well, if we well, I can explain it why. If we take k theta minus c and set it equal to 0, because we know that the sine of 0 is equal to 0, right? And so if we want to say that theta was 0, that's what we'd say. We'd say k theta minus c equal to 0, and we would solve that. We'd get k theta equals c if we added c to both sides, and then we would divide by k, and we would get theta equals c over k. So everybody got that? This is a formula. Everybody write that down. Phase shift. By the way, what is phase shift again? Okay, everybody tell your shoulder partner what phase shift is. Okay, turn around so Maddie can tell you. And you can tell her. Okay, you should have said that phase shift is a horizontal shift. Okay. Okay, so it is equal to C over K. Phase shift is equal to C over K. Everybody got that? How do you guys want to, they don't have an abbreviation for phase shift. Do you want to call it PS? We'll say PS equals C over K. How's that sound? That's our formula. You're going to be using this one just like you used period equals 2 pi over K. You're going to be using that one. So let me show you this problem right here. What if I gave you a problem like y equals sine of theta plus pi? And I want to know, what is the phase shift? I'm going to give you guys 30 seconds to see if you can figure this out with your shoulder partner. Go. I'm going to ask a few of you. I'm going to start with Rachel. What do you think it is? Let's ask Kaylani. Let's ask Jerica. Negative pi. Okay, that is right. How'd you get that? Well, I didn't say you were. I'm just asking you to explain it. No, I'm not. Did Andrew give you the answer? Maybe you should put your phone away. Okay, what? Okay, but yeah. Well, you guys, we're going to use this formula right here. Okay, the answer is negative pi. Because look, we know already what C is. What is C, everybody? It's a negative pi, because since this is theta plus pi, it's really theta minus a negative pi. Does everybody understand that? Okay, so that's negative pi. And what is K? 1, because the number in front of theta is 1, right? And so that just comes out to be negative pi. So that's the phase shift. Okay? Dylan. You could say pi shifts, it shifts pi units to the left. You could say it like that, but yeah, I would accept that on the test. But it's negative pi. If you were taking a standardized test, they would be looking for the answer negative pi. Okay? All right. So, and then graph this. What would the graph look like? Okay, we know, this is what I want you guys to practice, because you guys are going to be doing this. Without graphing it in your calculator, we know that the sine function looks like this. Here's pi. Here's 2 pi, right? Okay, if all of a sudden I shifted this to the left pi units, okay, am I going to be starting here or up here or where? I'm going to start here, and which way am I going to go? It's going to look like that, because what's going to happen is this part right here that's crossing through right there is going to shift left to right here, right? And it's going to be going down. So this is all just going to translate. I could probably even just drag this way, right? To show you. Whoops. I have to grab it down here. And that's what happens. Got it? So that's what it did. It just shifted left like this. Pi units. Okay? All right. That's how you find phase shift. Let's try another one. Let's say I gave you y equals cosine of 2 theta. 2 theta minus pi halves. Now I want you to find the phase shift. What is the phase shift here? And see if you can draw a picture of the graph. You're going to probably have to know what the period is too, right? Okay, I want to know the phase shift. I'm going to call on Eric. What's the phase shift? Pi halves over 2. Okay. So because the phase shift period is C over K, in this case C is positive pi halves and K is 2, right? There's C, there's K, right? Now, what does pi halves divided by 2 simplify to be? Pi fourths. That's because if you have pi halves, you're going to invert and multiply. Really think of that as 2 over 1. You're going to invert and multiply. 1 over 2, pi times 1 is pi, 2 times 2 is 4, and so the phase shift is pi fourths. Okay, got that? Why don't I times the very top and the very bottom and just make it pi? No. No, when you divide a fraction by a fraction, if you have a over b divided by c over d.
Yeah, but if it was just A over B divided by C.
Well, if it was divided by c, that means it's c over 1. And if you invert and multiply, so now you're going to times, you're going to go d over c, right? That's how you multiply fractions. Okay? If in this case right here, where I'm going pi halves divided by 2, you have to invert and multiply. It's going to be pi fourths. Okay, what's the period of this function, you guys? Pi. Why is it pi, Dylan? Yeah, 2 pi divided by k, and k is 2. Those cancel out, and you get pi. Very good. Okay, so let's talk about what this graph would look like, okay? It's a sine function. Sine functions start at 0, 0, right? Okay, but, oh, it's a cosine function. Cosine functions start at 1, right up here, right? Okay, so it's a cosine function that starts right up there. But what we've done, first of all, is we've taken, instead of going, if this was pi and this was 2 pi out here, okay, before, I mean, a regular function would go like this, like that, right? But now our whole period now is pi. That means that whole thing has to take place between here and there, right? And now we have to take this part and do what with it? Shift it which direction? To the right. How much? Pi fourths. Now, if we were to take, this would be about half pi right there, right? So pi fourths would be right here. So if I shifted that, I'm going to use the red to get our final thing. It would go from right here. We'd go down and come back up and end about right there, right? Something like that. Because it would have to go to 5 pi fourths, which is about right there. Can I get that? Getting the hang of this? Okay, now we've learned about the phase shift. This first part, I'll underline it up here. Learned about phase shift. Now we got to learn about translation, a vertical translation. And this is the easy part. You guys remember how to move a graph up and down? What do? Huh? Subtract or add a number to the function. So let's say I have the function y equals 3 sine of x. How am I going to get it to move up 2 units? Add 2. Okay, so if I did this, you guys, 2 plus 3 sine of x. Okay, 2 plus 3 sine of x, it's going to move up 2 units. Everybody, take your calculator out. We're going to put those 2 functions in here. Go to your y equals, and I want you to put in 3 sine of x and put into plus 3 sine of x. And we graph them. We need to change our window, don't we? Okay, everybody go to your window button. And we are going to change the, what do we need to change right here, you guys? Yeah, the y's. Let's make them both go up the same amount. Let's go up to -5 and down to +5. Okay. Are these basically the same graphs? What's the only difference? It's but by 2. Okay, and I got to teach you another word right here. If I shift it up by 2, you guys, the equilibrium point for this graph right here shifts from being the x-axis to where? To y equals 2. Okay, does everybody get this? This line right here is called the midline. And it's at y equals 2. You need to know that word, midline. And that's at y equals 2. Jerica, and you're wondering why I'm skeptical. Okay. Midline is at y equals 2. Do you know what a midline is? Okay. So, guys, when we graph this right here, the new midline became at y equals 2. Huh? Because the graph shifted up 2. It had a vertical shift of 2 units. Well, 3 is just the amplitude, because 3 is being multiplied by sine of x, right? This is going to go up 3 and down 3 from the equilibrium line. And the midline is the equilibrium line. And so the 3 sine of x, it's just going to start right here. It's going to go up 3 units and down 3 units. Okay? So it goes up to 5 and down to -1. Those are each 2 plus 3 is 5, and 2 minus 3 is -1. Do we understand that? Okay, we'll test you out right here. Everybody do this problem right here. I'm going to give you this function right here. Y equals, do not graph this in your calculator. I want you to do this one by just looking at the function. 2 cosine of theta. 2 cosine of theta minus 5. Y equals 2 cosine of theta minus 5. I want you to find 2 things. I want you to find the vertical shift and I want you to find the equation of the midline. Those 2 things. I'll give you a minute on that. It's actually -5. Okay? Why is it -5, you guys? Yo, I want to know what the vertical shift was. Huh? It's -5. So it's, you guys, hey, look, you guys are getting confused between this. Watch. You guys are getting confused between this. What's the difference between these 2 equations? Yeah, the one over here on the right, this blue one, this one is a horizontal shift. Why? Because it's taking the cosine of theta minus 5, not just theta, right? This one over here is only taking the cosine of theta, and then the whole function's shifting down 5 units. This minus 5 is outside the cosine. I could have written it like this. Y equals -5 plus 2 cosine of theta. That's the same thing. Okay? Do you understand it now? Okay, so this right here, you guys, that's going to be a horizontal shift. 5 units to the right, whereas this one is a vertical shift of shifts down 5. However, you would write it as a vertical shift as -5. Okay, what's the midline? Where would the midline be? The midline would be y equals what? -5. Here's -5. Here's -7. Here's -3. Okay, this is a cosine function, right? And so a cosine function, the midline is going to be at -5. So here's the midline right here. Everybody got that? That's the point that the graph oscillates between. We'll call it the equilibrium point. Okay, and then the graph still notice, you guys, what does the 2 do to it? What's that? It's amplitude, right? So this function is going to go down like this, down to -7, and back up like this. Andrew, what was that again? Cosine of 2 theta. Cosine of 2 theta changes the period. It changes how much it's scrunched down this way or goes out this way. It's like what do you call that, accordion? How far it stretches out horizontally and how far it stretches in. Okay, shrinks in. That's if I put the 2 in front of right here, but what does this 2 do? It makes the graph go up to 2 and down to 2, right? But if my midline is -5, it makes it go up to -3 and down to -7. 2 units up, 2 units down. So this is the amplitude. A is the amplitude. -5 is the vertical shift. My midline is at y equals -5. You guys understand that? No? Guys, look, it's just like this. Guys, what if I had x squared -5? What does that do to the quadratic function? It shifts it down 5. That's all we did right here. What did we do? We -5, and what did it do to the function? Shifts it down 5. That's all we're doing. Do you understand that? Yeah, if it's in the parentheses, it's a horizontal shift. Okay? All right, now. Okay, we've learned about those things. So I'm going to put this all together. You guys now know, about amplitude, right? You know which one the amplitude is, right? Let's move this down. Let's write out an equation in this form right here. Y equals A times the sine of k theta minus c plus h. Okay, now let's talk about what each one of these things do. Okay, A is what? Amplitude. Okay, what does K change? Changes, period. How often it oscillates back and forth. What does C do? Phase shift or horizontal shift. You can think of it as a horizontal translation. And what does H do? Vertical shift. Okay? Or translation. Vertical translation. Goes up or down, right? We got that? Okay, did you write down this equation? You can write one down for cosine as well. Because now we're going to put it all together and see if you can do all 4 of these things. You got it? Andrew? Yeah, it works for sine and cosine. Yeah, you can actually make a sine or a cosine function look exactly the same by doing a horizontal shift. Okay? Uh-huh. We are. We're going to have a test on this. Okay, I want you guys to do this. I want you to state the amplitude. I'll go back a slide in just a second. We're going to state the amplitude, the period, the phase shift, and the vertical shift for y equals 4 cosine of theta divided by 2 plus pi minus 6. Okay, I want you guys to state those things for that. I'm gonna pause this for a second and let you guys work on it. Got to turn it on for those at home. Theta divided by 2 is the same thing as 1/2 theta. Therefore, k is 1/2. Got it? Okay, so we have, once again, I'm just going to review this. Okay, a was really easy to find. It's just the number that's being multiplied by the cosine or the sine. It's 4. Okay, that means this thing's going to go up 4 units and down 4 units, right? Okay, from the equilibrium point. Okay, h was really easy to find. The vertical shift is going to shift down 6 units. Okay, the period is just equal to 2 pi over k, and k was 1/2, so 2 pi divided by 1/2. Invert and multiply, you get 4 pi. Do you understand that? Okay. You take the bottom fraction. What's the bottom fraction? You invert it. What does it mean to invert? Flip it over and times it by, so it's 2 over 1. What's 2 pi times 2? 4 pi. Got it? Okay, so there's the period. And then phase shift is equal to c over k. Well, c is, don't forget it's a negative pi, because it's really theta halves minus a negative pi right there. Okay, so it's negative pi divided by the k, which is 1/2. Invert again. So you're timesing by 2 over 1 times a negative pi makes negative 2 pi right here. Got it? Okay, now, you should know how to do that. You guys got that part down? Okay, I'm almost done. Sorry, this is taking a lot longer than I wanted it to today. One last type of problem you guys are going to need to know how to do. Okay. This one right here, I want you guys to write an equation. You got to do the opposite. Write an equation of a sine function it's just going to be the opposite of what you did, with amplitude of 4, a period of pi, of phase shift, I'm just going to put PS for phase shift, of negative 8 over pi, or negative pi over 8, and a vertical shift of 6. Okay? So you guys got to write an equation now. See if you can do this. Okay, this is how we do it. Okay, so we have the form y equals a sine of k theta minus c plus h, right? So we know a. A is the amplitude, it's 4. So 4 sine. K we don't know, but we know we're going to use the formula period equals 2 pi over k, and we know what p is. It tells us up there that period is pi, so we're going to go pi equals 2 pi over k. If I multiply both sides by k, and then divide both sides by pi, then you're going to go like this. Pi's are going to cancel out here, k's are going to cancel out here, pi's are going to cancel out here, and what are you left with? K equals 2. So now I know that k is 2. Now, I need to find c. Well, I know the formula. Phase shift equals c over k. I know what phase shift is. What is phase shift? Negative pi 8. So I have negative pi 8 equals c divided by 2, because we know k is 2. What am I going to do to solve for c on that one? Times both sides by 2, right? And 2's cancel out here, and 2 will go into 8 4 times. And so what do I get c to be? Negative pi fourths. It's a negative pi fourths, and we're minusing a negative pi fourths, so that makes it plus pi fourths, right? And then the last part's easy. Vertical shift to 6. What do? Add 6. And that right there, you guys, is how you find an equation given those 4 things. Okay? Now, for your assignment, I'm just giving you guys a minute to write this down. Some of you guys are still writing it. You just need to know those 2 formulas. P equals 2 pi over k, and phase shift equals c over k. If you know those 2 formulas right there, you can write all this stuff. Got it? Okay, here is your assignment. Got to go down here to the bottom. I didn't even use all my graphs. There's your assignment. For those at home, when you're not here, I do expect you to watch the video and do the assignment. Okay, I'm going to pause it. So